Problems 5 through 11 deal with vocabulary terms, so we are going to combine them all into one video. So we're going to first talk about problem number 5, problem number 8, and problem number 9, because all of those problems deal with the term opposite. Now, numbers that are opposites are the same distance away from 0. They're on opposite sides of the number line. So let's look at number 5. Number 5 is asking for the opposite of positive 3. Now on this number line, there isn't a positive sign next to that 3, but they are the exact same thing. The positive 3 is equal to 3. So even if you don't include the positive sign, I'll know what you're talking about. Okay, so the opposite of 3 is going to be the number that is the same distance away from 0. 3, or positive 3, is going to be 3 spaces away from 0 in the positive direction. So we want to know what number is 3 spaces away in the negative direction. So if we move negative 3 spaces, we are going to land at the negative 3. So the opposite of 3, or positive 3, is going to be negative 3. All right, number 8, we are looking for the opposite of negative 10. Now my number line doesn't necessarily go out that far, so we're just going to add it in there. There's my negative 10, and there's the 10. Pretend they were there the whole time. That looks like a 16. Okay, we're going to redo that. All right, so we are looking for the number that is the same distance away from 0. So then that distance is 10 spaces to negative 10. So we are looking for the number that is the same distance away from 0 in the positive direction. The number that is 10 spaces away from 0 in the positive direction is going to be that positive 10. So the opposite of negative 10 is going to be positive 10. Now number 9 is a little different. Number 9 deals with the sum of opposite numbers. So if you recall some previous math vocabulary, the sum is the answer to an addition problem. So keep that in mind. So it is asking for the sum of a number and its opposite. Well, let's look at number 5. We know from what we solved earlier that positive 3 and a negative 3 are opposites. So if I add those together, what do I get? Well, they in a sense cancel each other out, so we get a 0 for that sum. So let's check back with number 8. So we had negative 10, and we found the opposite to be positive 10, or just 10, which again adds to be 0. The same is true for every number and its opposite. Every time you add a number and its opposite, the sum, or the answer to that addition problem, will be 0. So number 9, answer is 0. All right, moving on. The next problems we're going to look at are problem 6, and number 7, because those problems deal with the term absolute value. Now, the absolute value of a number is the distance between that number and 0. So for number 6, it is looking for the absolute value of negative 8. So negative 8, let's find the distance between that and 0. So starting at negative 8, we're going to go 1, 2, 3, 4, 5, 6, 7, 8. That is going to be 8 spaces away from 0. So the absolute value of negative 8 is going to be 8. All right, for number 7, it's looking for the absolute value of 12. Again, I'm going to add to my lovely number line. So we'll pretend I went all the way out there to begin with. All right, so we are looking for the distance from 12 to 0. So if we start at 12, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there are 12 spaces between 0 and positive 12. That means the absolute value of positive 12 is 12. Now, you may have noticed, even though this is a negative 8 and this is a positive 12, their answers or their absolute value are both positive. That is always going to be the case because the absolute value is a distance. It is always going to be positive. You can't have a number that is negative spaces away from 0 or a negative distance away from 0. It always has to be a positive difference. So no matter what, your absolute value is positive. All right, last few questions. Number 10 and number, that is 10 and number 11. So number 10 deals with the vocab word integers. So if you don't remember, the integers, I know it looks like, it's integers technically. So the integers include numbers like 1, 0, -2, 5, 17, -20, all the positive and negative whole numbers. The rational numbers are on the outside of that. They include all the numbers that can be written as a fraction. So you got 1/2, 3/4, you got a -1/3. All of those numbers are rational. Also note though, the way I drew this, it's a bullseye. So the rational numbers not only include those fractions, but also include everything on the inside as well. So all of the integers are also rational numbers. Right. Knowing that, let us move forward. So number 10, true or false, all fractions are integers. Well, fractions belong in this outer ring, and integers are in the inner ring. So this statement is actually going to be false. Fractions are not integers. All right, number 11, true or false, the rational numbers do not include any negative numbers. Well, as I already stated, the rational numbers include every integer, and we have negative numbers as integers. So the rational numbers do include negative numbers. So number 11 is also going to be false. So just to recap before we end this video, number 5, question number 5, the answer is -3. Number 6, the answer is 8. Number 7, the answer is 12. For number 8, the answer is 10. For number 9, the answer is 0. For number 10, the answer is false. And 11 is false as well.